make sure you open the same data set. Are you? Yeah, open this file. Custom load return.
Yeah.
Okay, so let's redo the analysis of CFA. The first step is click the factor on the menu bar and select confirmatory factor analysis. And of course, you can rename the factor. The default will be the factor 1. I would like to move back to the middle whiteboard and to take a look at the research framework of our example. So you can see this is our model, right? For a brain image. Let me ask you, how many factors do we need to create based on this framework? How many factors we need to create in CFA?
How many factors?
Yeah. We need to create for CFA analysis.
It seems like 12.
12?
Factor?
How do you count?
Like the B1, B2, B3. It's
No.
dimension, right?
Dimension. That's good. Yeah, dimension, right. Dimension also, that's in this framework, but in SEM we call it it's called factor. So we have different names: dimension, factor, first order construct. They are all the same meaning. So let's count: 1, 2, 3,
Yeah.
4, 5, 6, 7, 8.
8,
Yeah, 8, right? 8 factors. Okay. So we can use the name such as PI1, PI2, PI3 instead of factor 1, factor 1, factor 2, factor 3. So let's do it. And you can rename this one as a BI1. BI1. Okay. And select the BI1 indicator. We have 3 indicators for BI1. Just moved to this pane. And click the plus sign, add a factor again, rename, BI2. Okay. So BI2. Okay. Added factor, BI3. 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 Add factor again. Now will be the PV1. Perceived value, PV1. We have 2 indicators for PV1. And add a factor again, rename PV2. PV2. Add a factor, PV3. Also 2 indicators. Okay. PV4. Let's rename it PV4. Okay. Now the last factor, we call it custom loyalty. So LOY means loyalty. So LOY1 to LOY5 have 5 indicators. Okay, good. Now we have 8 factors in CFA model. For the model option, take a look. We don't need to do anything, so skip this part and click additional output. Yeah, we need this one. So we like to see the model fit. So additional model fit measure, you have to check this one, additional model fit measures, and R square, and AVE, and HTMT, and also reliability. Okay, good. Now scroll down to the last one called advanced setting. Only one thing we need to check is standardization. On the right hand side, you can find standardization for all parameters. So we need to click all. Click all. Good. Now we already do all the setting for CFA. You can see the report already show on the right hand side. Let me zoom in. Okay, again, that you how to interpret the model fit based on the chi-square test. How to interpret? Because we need to interpret, you have to write the output into your result section and try to describe or interpret the meaning. Yeah.
So, DF is the differentiation part?
P-value.
What the difference?
P-value. This one, you have to find key information here. Because it is for chi-square test, so we need to interpret the p-value. What does it mean? P-value.
I think p-value was upper than 0.5.
Yeah, it's a label, right?
Yeah.
So p-value have to greater or less than 5%.
Greater than 0.5, right? So it means the fractional model is significant.
Significant or not?
No.
0.6. That's okay. Try it.
Or it's not significant because it's greater than 5%. So
yes, of course.
So it should be like lower than 5%.
It should lower, or we need to greater the value greater than 5% in CFA scenario.
Oh, okay. Yeah, so it should be greater than 5%.
Should be greater than 5%. It mean the model fit is good.
Yeah.
The model fit is good. You got it? Model fit is good. It means the data fit our theory, measurement theory. We need to fit well. If it is significant difference, it means it not fit well. But usually, for example, in your case, in your research, probably your p-value will be significant different, because the p-value in chi-square will be influenced by your sample size. The larger your sample size is, it's more likely you will get a significant p-value. So this is only one indicator. So in our case, it's good. P-value is greater than 5%. So we have a good model fit. And you can scroll down. Okay, Xiao Qiao, how about you? How to interpret the fit indices? Do you remember? CFI, TLI, or we can just scroll down to look for something here. Okay, let's try this one. Let's try SEA and SIMR and GFI. How to interpret the meaning of this result? It's good or not? Why? You can reference to our course material. We have some best introduction about how to judge a model is good or not based on some indices. There's some threshold. Some index should be less than the threshold. Some index need to be greater than the threshold or a specific value. 如何解读这张目前这三个指标到底模型可以 small fit good or not？ 你有没有看讲义？因为我会去看讲义，因为一旦可能不太容易 memorize everything, so you have to go back to visit to see the 讲义。可以看那个我们那个 team 上面不是有讲义吗？有连结吗？那上面会有介绍，会有介绍说那个指标好或不好。Okay, how to interpret this result? If you don't remember anything, you just move back to the material. I guess it's for the CFA, right? Just move to the material of week 12, CFA here. Right. Scroll down. You can see we have key components just like this one, chi-square, RMSEA, CFI, right? Show us here. And scroll down. Refractive, formative. You see that? Okay. For chi-square, you can see a non-significant chi-square indicates a good model fit. So this is the first one. And GFI, the second. GFI, the value is closer to 1, it's good, it's better. So we hope to see the value close to 1. And CFI, it also expects the value above 0.9 or even 0.95. I mean, we have a good fit. These are 3 indices. Still, we have more. TLI is similar to CFI. The value is, we hope, is above 0.9. Indicate a good model fit. For IMSEA, the second one, IMSEA, we hope our IMSEA value is below, not greater, below 0.06 or 0.08. So the less value means the model is better. Okay. And also the SIMR below 0.08. So we have different indices standards. So we have to use this standard to evaluate our model. 看到了吗，小乔？那你来解读一下。That is your turn to interpret how well our model fit based on these fit measures. Can you tell me? Is it good or not? IMSEA, SIMR, and GFI. 模型配置好吗 ？Model fit 好吗？好。Why？ 一个一个来 ，one by one， 一个一个来。RMSEA is good or not? The first index, RMSEA.
Why do we have a lot of RMC? RMC.
Oh, okay. There's different notation from different software, but it's okay. It's RMSEA.
So which one that we have to consider?
You can take here. We have 3 values, right?
Mm-hmm.
But the first one is the value I checked. This one is called confidence interval, C5. CI. CI. So we use the first value.
Oh, the
First value. So I just check it here. You can see. Right. Let me tell you something. The relationship between CI and p-value. P-value and CI. P-value. P-value, for this model field, we need to greater than 5%, right? Greater than 5%. For RMSEA, the p-value is 1. So, it's greater than 5%. It means the model fit. This for p-value, we have different way to make judgment. Second for CI, or confidence interval. That we are lower and upper. We have two values. Lower, upper. If the confidence interval does not include 0, it means not significant. Okay, for our case here, the lower bound is 0, right? And the upper bound is 0.02. Is this significant or not? For confidence interval. Is this significant or not? Based on my explanation, if the confidence interval includes 0, means not significant. So, significant or not? Significant. Yes? Does this interval contain 0 or not? Yeah, of course, here. Yeah, contains 0. So it's not significant. So whether you check this one or this one, they will get the same result. P-value, even a confidence interval, you will get the same result. P-value not significant, of course. CI also not significant. They will both have the same result. Got it?
Also, the p-value and the CI have the same result.
The same result, yeah, of course. They should not have different result. So when we learn statistics, the instructor usually will tell you, you can depend on this value to make judgment, or even you can depend on this one. Especially when your model have mediation effect. We need to check the confidence interval again. Of course, we need to make sure the confidence interval does not contain 0 for the mediation effect. It means it's significant. The mediation effect is significant. It's a mediation effect, it means indirect effect. Right? Indirect effect. We'll talk about mediation effect for this week, but I guess maybe we have to talk about this one next week. But for course material, I already upload the mediation, right, for this week. Danu, yeah, okay, ask you the same question. P-value should greater than 5% or not, based on CFA model fit, not CFI. P-value should greater or less than 5%. For CFA model. greater or less than 5%? Less than? Less than 5% means significant difference. And this is not, of course we have hypothesis, yes. But in our case, for the CFA monofit, we have no hypothesis and a hypothesis alternative. For this hypothesis here, you can see here, the null hypothesis H0, it means the data, our sample data, fit the measured model, fit. For alternative, data does not fit measured model. So we should expect p-value greater than 5% or less than 5%. Know what? I don't know. I'm not pretty sure your answer. You're not sure. Can you interpret the hypothesis here? Hypothesis. This hypothesis. No hypothesis and the alternative hypothesis. The no hypothesis means data or sample data, because we collect data. It's sample, only sample, not the whole population, right? So it's sample data. And we have drawn the model, the measure model. Yeah, we will draw the measure model. So the null hypothesis means sample data fit well with the measure model. Then we just specify where. Okay, let me show you the model. I just specify the model here. I specify the eight factors. But you cannot see the measure model, right? Of course, if you like to see it, you can just click the plus, model plus. Because my computer is maybe the memory is overloading, so you cannot see the very clear model, measure model here. This is our measure model, is theory. We use the data and we specify it based on the theory, the measure model. So the alternative hypothesis, the sample data does not fit well with the measure model. This is measure model. So do you expect the p-value greater than 5% or less than 5%? Greater. Yes, yeah, right. Exactly. We expect we cannot reject the hypothesis, no hypothesis. We cannot reject it. We expect this result. Okay. The confidence interval, CI, let me just move back again. Yes, okay, something here. Right. You may see this confidence interval. CI stands for confidence interval. We will have two values, the lower bound and upper bound. Lower bound, upper bound. So, lower bound, upper bound. And we have lower bound is 0, upper bound is 0.02. If the confidence interval does not include 0, mean not significant. Let me say again. If the counter interval does not include 0, means not significant. So based on the information here, is significant or not for CI counter interval? Not so, yeah. So the result should be the same with the p-value. You can see that the p-value is 1, right? Yeah. So 1 also greater than 5%. So either you will get the same result by using p-value or confidence interval. Got it? Yeah. So this is a very special case. Any question? Any question? You don't be afraid to speak up. Any question?
It contains 0.
Come 0, it means not significant. So because the lower bound contains 0, so not significant. Not significant, it means we cannot accept this one. We have to accept this one. Not significant. This is significant. So that's good. Question. 这样子听得懂吗 ？Okay. Any question? It's very tricky chi-square in this scenario. Only chi-square for the CFA or SEN, we expect not significant. Nothing. But in other scenario, usually we expect significant for chi-square test. Got it? Based on I have introduced chi-square before, right? Chi-square, we have two dimension, right? Continuous chord, categorical is for IV, right? And for DV, also a continuous for categorical. Right? So both IV and DV, both kappa, we need to apply chi-square test, right? You remember this one? Next example. There's IV for gender. Gender is categorical. Yeah. Right? Categorical. And DV, smoking behavior. Yes or no? Still categorical. Still categorical. So kaka, two variable, both categorical. Gender and smoking behavior. Yes or no? Yeah. So if we test the chi-square and there's the result is a significant difference. It means the gender with smoking behavior, there's a relationship, there's an association. There's association between gender and the smoking behavior. If the chi-square result is significant. If the chi-square result is not significant, it means gender and smoking behavior doesn't have any association. Got it? See? Okay. Okay. 小乔来，我刚刚讲的部分，稍微说明一下。我刚才讲 p-value 跟 CI 怎么判断有没有显著 significant。但是我们的现在目前的例子是 CFA， 它是要低还是要高？我写在白板那边。要大，那为什么要大？如果大的话，不显著的意思。If p-value greater than 5% is not significant， 不显著 ，so we cannot accept 这个对立假设，我们一定要维持这个虚无假设。 虚无假设是 sample data fit measurement model well 很好，配得很好，所以这个情况必须要不显著 ，p value 不显著，所以 p value 1大于5%不显著。CI 它那个区间包含0的话也是不显著，因为它的 lower bound 0就是包含0的，这两个结果都一样，不过一个有显著，一个不显著。Any question? Okay? Okay. Yeah, it's really important that you can clearly have clear understanding about the index meaning, so that you can interpret your result. How about the next one, R square? How to interpret R square? Janice. For example, this one. What does it mean, R squared, in this case? Do you know how to interpret the meaning of R squared in this scenario, CFA? We use three indicators to measure BI1, right? BI1. We use three indicators. BI1, 1, BI1, 2. BI1, 3, right? So what does R square mean in this scenario?
Is it like the BI1?
Yeah.
Like 3 of the indicator is significant.
Okay. Significant. Significant or not, we need p-value or confidence interval. But in this case, it's the proportion of variance among BI1-1, BI1-2, and BI1-3. We have three indicators, so we have three variance. The proportion of variance that, for example, the variance here, this indicator has its variance. The variance should be from 0 to 1. And the BI1 distribution means the construct, this one vector can explain around 80% of variance of BI1. Okay? And for BI1-2, the BI1, the construct can explain. This error here is mean can explain. Can explain the variance of BI1-2 around 74% variance. The proportion that you cannot explain, for example, around 26, right? Can I explain? If the plus 1 is 100%, right? Am I right? Yes? So this variance could be explained by this one, but we still have 26% cannot be explained by factor 1. We give it a name. We call it measurement error. Something we cannot capture by the factor. Okay? That's R squared. Of course, for the regression analysis, so Danoni, have you ever done regression analysis before? Yes, linear regression. Yes, of course. So I suppose you already understand what is R squared, right? R squared.
They didn't go into such detail.
Uh-huh.
They did not teach us in detail about linear regression.
In the linear regression, yes.
Only the linear regression for now, y equals.
We don't need to go into the formula. We just explain the meaning of R squared.
Only about the intersect concept later.
Mm-hmm. Yeah, the we finish the topic about CFA, we will talk about regression right away. But now we haven't mentioned, because the R-squared here, we need to just mention a little bit about regression. Especially the simple regression and linear simple regression. Okay, so we have x, right? X predict y. Simple regression, only one independent variable. Only one, it means simple. Okay, and linear means the relationship should be look like this one, x and y, either this way or this way is called linear. Right? Okay, so this code is a regression model. If the R square, the result is 79%. What does it mean? If the R square is the result of the regression is not 79%, what does 95% mean?
Not 70.
It's 79%. What does it mean?
Means it is closer to 1.
Yeah, closer to 1. But what does it mean?
It fits the
It fit what? Fit what?
regression.
Yeah, we regression. Yeah. Now we can say we have y. We have two regression where y hat means is a predicted value. Predicted value. You know, I will talk about this very detailed in the data science course, because data science course all talk about prediction, predict something, predict specific value or predict a label. Well, in this case, it's predict value, of course, equal to regression model. This is not regression model. So we have predict value, y hat is regression model, and this one we have actual y. So the regression model can explain around 79%. What does that mean? Of course, we expect the value close to 1, but what does it mean? 79%. It means this model can explain the variance of y. The variance of y. Around 79% is quite high, you know, quite high. You know, in the social research, we cannot see that high of R square. Usually in our research, maybe only 20 to 50% of R square for a regression model only. Okay, got it? So that's called the R square. R square. Got it? Okay, got it? Got you, okay? 听得懂吗？啊，小乔，解释模型可以解释那个真正 y 的变异数多少？最多就只有1，把它全部都解释。0到1，那79就很高了。那一般你们的研究不会那么高。Okay. Okay, that's the factor loading. Okay, you can see the residual variance here, right? The residual is the measurement error. Something we cannot explain by the factors of for the indicators. And also the AVE, Okay, AVE, let's visit the material again. Model fit, you see that? The cutoff for the model fit, revisit again, chi-square, we need to greater than 5%. CFI, TFI greater than 0.95. Iron SEA are less than 0.06. SRMR less than 0.6. And for the construct reliability, we suggest all the alpha or Cronbach alpha above 0.7. And we have another called compositive reliability. Okay, so also expect the value is greater than 0.7. So if all values above 0.7 indicate good reliability. For the construct validity, we just mentioned about the AVE, average variance extracted. You see that? Average variance, it means the indicator's variance. Extracted means the factor. Extract, it means the factor. Reported AVE for each construct, the value above 0.5 suggests the construct explains more than half of the variance of its indicator. You see that? See that? Read it again. If we have the construct, its AVE is greater than 0.5, suggests the construct explains more than half, means 50%, right? Half means 50% of variance of its indicators. Okay? So let's check it out for the result from the JASP. See that? Janice, how do you interpret the AVE for A factors or A construct? How do you interpret the result here? It's good or not?
I think it's good enough, but it's not that very good.
Mm-hmm. Okay, why? The smallest value is for PV3, yeah, around 0.59. It's closer to 0.6, right?
Yeah.
And you can just switch back to here, not here, this here. 0.5 suggests. So it's suppose we have convergent validity. If all value of factors above 0.5, it means we have convergent validity. Okay? So take 10 minutes break.